So, looking back and remembering in our notes, because this will help us a lot, does differentiability imply continuity? Yes. Does continuity imply differentiability? No. Could be, but it doesn't imply it. Yes, thank you. I appreciate it. Now, if we're not continuous, then we cannot be differentiable. Agreed? Alright, so little recap. I'm going to show you one of the hardest AP questions I've seen on a test, in my opinion. Okay, I think like 20% of the kids got it right, even though it might have just been guessing, who knows. Okay, so this is the question. They gave us a piecewise function, and they want to know which of the following is true. Well, here they're saying the slope from the left is 2. Here they're saying the slope from the right is 2. So, by the limit definition of differentiability, they're saying the derivative of 3 is 2. Okay? If this was true and this was true, then this would have to be true from the definition, right? Okay, well, let's go look at this f of x. Most kids would only just say, hey, f prime of x, well, what's the derivative of 2x minus 2? 2. And the derivative of 2x minus 4? 2. Oh, look at that. They're both 2, so yeah. That's what most kids would just want to jump into, okay? And it's fairly common in your time test. You agree? Slopes 2, slopes 2. Good? What's wrong?
They run parallel to each other.
They run parallel to each other.
Never actually like meet.
Okay. So here, if I look at what's happening at 3, let's see, 3, if I plug it in, I get out 1. Slope of 2, 1, 2, okay. And then this guy over here, when I plug in 3, I get out, what? 2. Slope of 2. Okay. Something like that, I'm sketching, but you got the idea, right? What failed to happen?
They didn't meet.
Okay. What failed to happen is it was not continuous. And if we're not continuous, then we are definitely what? Not differentiable. So let's go back to it. So then we'd say, well, we are definitely not differentiable. That derivative doesn't exist. But what about the first two things? Could one of those possibly happen? What about from the left? It's not even defined there, is it? So could we get the one from the left? No. Okay, like we can't even plug in f of 3 there, right? But what about from the right? Could we do that one? Yes. So this was the right answer. And I just wanted to have that little discussion now that we've kind of seen some different things. Hard question to put it all together. Does it all together kind of make sense now? Okay. All right. Here, really quick, do this one for me. Right off to the side somewhere. Let's make sure we have that down before we finish our notes. Just had one like it on your quiz. So it's asking you to find f prime of what value? 9, because that's actually actually the square root of 9, which is 3, right? When f of x is square root of x. Are we getting that down? Okay. Make you feel smart now? After I gave you that one? Are you like, oh, I can do this? This is still somewhat tough to kiddos too, okay? So, good. I can tell like the hardest one. Okay. Woo! Should we go fishing soon? Along for the ride. Alright, so we left off. Next page. Alright, right here. So where I'm going to give you some basics on position, velocity, acceleration. And if you see on Tuesday up here on the board, we're going to do more on the position, velocity, acceleration. Okay? So I'm going to give you like some pre-knowledge of stuff that maybe you've seen, maybe you haven't. And then we're going to get to more of the calc stuff again on Tuesday. Okay? So I'm going to do that today, and we're going to do some of those piecewise today. That's what I want to get through. Okay. So when I look at this, how many of you guys have seen these equations first off? You've seen them. You should all raise your hand. They've always been in some kind of Algebra 2 textbook or Algebra 1 or something, I promise, okay? You've done a question at some point with these. What are these, though, you may not have known. How many of you know what these are? Where do you know it from? Physics. Who else is taking physics? You should know these, okay? If you had physics. So, first off, let's just get through some notation stuff. Because when I first heard these, I heard people say V sub t, or V sub naught, blah, 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 and I was like, what are they saying? What is that? Okay, this, when we have like something down here, is a subscript. When we have something up here, it's a superscript, okay? So when they say this, they're saying x sub for subscript, and then when it's just a 0, it's not. Okay? Not is telling us initial when I see the not. So it's just some notation to help us. So if I say V sub not, and I'll try to say it clearly so you're not like, what did she say? What is going on here? Because I had a college professor and I had no idea what they were saying. Okay, then you know it's sub for the subscript. Okay, so then we have this initial velocity, initial position, and this guy on Earth, gravity is pulling at a constant. Okay, pulling down, hence the negative. If you are in feet, then the constant with gravity is this negative 32 feet per second squared. And if we're in meters, it's negative 9.8 meters per second squared. Okay, so those are just given things. If you want to go explore, great. So then we have these position functions. The position function is taking the 1/2 times the gravity constant to get in front of my t squared. Then we have the V naught times the t, and the plus just the S naught, not times anything. So V naught is what again? The initial velocity. S naught is the initial position. Okay? All right. So those are where they came from. So velocity now is the change in position with respect to time. So if I just say velocity, I'm talking about an instantaneous velocity. You don't always see it. Okay, they're never going to say find the instantaneous velocity because it's kind of redundant. So if it just says find the velocity, it's talking about some instantaneous. So if this is kind of like my position function, the slope of a tangent, right? That would be a instantaneous velocity. Now, if I did a secant, then it's going to be the average rate of change, which is average velocity now. Okay, so I'm throwing in some more words. Okay, so to find the instantaneous velocity, we take the derivative of position. And what would be a possible label for velocity?
Meters a second.
Meters per second. That's another label.
Miles an hour.
Miles per hour. What's another label?
What usually in a second?
Somebody else.
Feet per second.
Feet per second. What's another possible label? Okay, all of these are possible labels for velocity because it's a change in position over a change in time. Now, acceleration is the derivative of velocity or the second derivative of position. Okay? What would be a possible label for acceleration?
Meters a second
Meters per second
squared.
squared. Because now it's change in position over change of time with change of time again. Okay? Or feet per hour squared. Okay, so when we're dealing with acceleration, we're going to have that denominator squared because it's time for time, basically. Change in position with respect to time with respect to time. Okay, the next one is speed. Speed is the absolute value of velocity. So let's say that I had some velocity equation that looks like that. What is the graph of speed going to look like? If it's the absolute value of the velocity. It's always positive, so I know that, oops, this guy is where we're negative, this guy is where we're positive, right? So the positive gets to stay positive. What happens to this negative part?
It
Flips over to make it positive. So speed is just the absolute value of velocity. It's velocity without a sign.
just has magnitude while velocity is magnitude in direction.
Yes, very good. Perfect. Okay. Okay. So average velocity is the average rate of change of what with respect to time? Of what? Location, or I'm going to use position. So when I do average velocity, I'm going to subtract the position over time. So again, if I had some position function, and let's just say I wanted A to B, and I have some C, okay? We did this a little bit yesterday. We said this slope was the what? What? Average rate of change. We said this slope was the, I don't like that one. Was the what? Instantaneous rate of change. Let me try to get it a little bit better. Okay, I think that's a little bit better. We were using rate of change yesterday. Now I'm introducing a new word called velocity. So this slope, which was the average rate of change, is now going to be called average velocity. They're the same to find it by doing change in position over change in time. Do I even use a velocity function? No. Guess what a lot of kiddos want to write here? They want to do this for average velocity. But guess what that is? Average acceleration. That's average acceleration. And I can't even tell you about a third of you will still try to use this formula on the test for average velocity. Don't be in that third. Okay? Average velocity does not involve a velocity function. Average velocity is change in position over change in time. Now, instantaneous rate of change is what we were just seeing. So this was our instantaneous, right, rate of change. But now we're going to call this our instantaneous what? Velocity, which is redundant, so we just call it the velocity. And we do that by finding S prime of C, which is equivalent to V of C. Can you see the difference? See? Can you see? Okay. Okay. Does that make sense? They're both still labeled like feet per second, miles per hour. Both the instantaneous and average, but the average is looking at the slope over a time period. The instantaneous is just at one particular, which is why we take the derivative. Okay? Okay. A watermelon's dropped from the building that is 2,680 feet tall. Okay, I got this building going on. I got this watermelon. I don't know what a watermelon looks like very well. Okay. So, I have a watermelon, and it's going to be dropped. Maybe. Okay, Lyric's going to go and just kick it off. Alright. Let's boot it off. Alright, where's your little hay button? Okay. So, Lyric's going to roll that watermelon off the top of the building. Just like. What do we know? We know the initial position was what? 2,684 feet. What's the initial velocity? 0. And what formula am I using if I'm in feet? We're using what? The S of t equals negative. So the negative 32 is the constant times the half, which would be negative 16t squared plus v naught t plus s naught. Yes? Look back at our notes that we just had.
Yeah.
Oh, wait. You want me to show you? This one right here.
Yeah. I just didn't turn away.
Oh, okay. So, give me the position function now that we know that information. Negative 16t squared plus 0t, right? Plus 2,684. Let's find our velocity. How do I find the velocity if I know the position? I take the, that's average velocity. If I just want velocity, I take the derivative. That's S prime of t. 2 comes down, negative 16, woohoo, right? T, that's just a number, so it's 0.
Right. Okay, that just made it.
And it didn't ask for it, but we're going to go ahead and say what's A of t? would be what here?
32.
Negative 32. Oh, and now have we come full circle? Okay. Okay. If I wanted to label, and let's just say we're in seconds, okay? This one would just be is position feet per second? Position is just feet. Velocity would be feet per second. Acceleration would be feet per second squared.
Once we get the first equation, we take the derivative, like all, if we want to find whatever.
And do you guys ever watch Law and Order SVU? Do you know that show? Okay, I love that show. So this is what I always think of. I always say SVU, but my U is... So that's what I do for my mnemonic device. So position, velocity, acceleration. And for the S, you can think this is the starting position. Okay.
You watch Bones.
No. Okay, but not that I don't want to discredit this, but we're on a little time crunch, so we're going to keep going, okay? You can tell me about it. Okay, so we know these functions. First one says, what's the velocity of the watermelon at 6 seconds?
6 seconds.
The velocity.
Yeah, we already have it, what, right there?
Just plug it in. You just plug it in that thing.
After 6 seconds.
The answer was right there the whole time. That's what you looked at.
So this is just the velocity. Boom, just velocity. And you guys can use your calculators for now for time purposes.
12 plus 192. Yes. No, I'm saying they're both in the same genre, but it's they'd be competitors.
Okay, and how do we label that? Per second. Alright. The next one now says, what is the average velocity? Do not mess this up. Okay. So much of like, okay, so, write this correctly, please, I beg you. Please write this correctly right now. Go.
S of negative.
It's S of A, is that one. It's like the S of
From the
So S
time
of
drop
B
to 2
minus
seconds
F of A.
is what interval?
0 2.
Okay. That's what we're struggling with.
That's what.
Okay, yeah,
Alright,
that's what we were.
So
Okay.
nice.
I did S of 2 minus. What? Sure.
Average velocity, right? V of 2 minus V of 0 over 2 minus 0?
No.
No! That is average acceleration.
Acceleration.
Hey. No, just keep it consistent.
Oh yeah, you could just.
Okay. So I got negative 32. This is going to be what? Feet per second squared? No, velocity is just feet per second.
Wait.
Okay, we're good with D. Let's do E and F. How long does it take for the watermelon to hit the ground? Don't say it. Rephrase without saying it. Set.
Ooh.
What is it? You said set it equal to 0. Okay, S, because it's position. How long does it take for it to hit the ground? Right? So we are in position. We want to know when is the position equal to 0. Huh? -16 t squared.
What is that? It's gonna be.
What's time measured in?
Seconds.
Seconds. Now it says, find the velocity of the watermelon at impact. Now what are we doing?
Is that?
That's, yep, if you just see velocity, it means instantaneous. So we're going to the velocity. And what am I doing with the velocity? I want to know the velocity at the watermelon at impact. Plug in this to the t. Now this is where you have to be careful. Do I have your attention really quick? Let's say that on AP you went and you truncated and you gave me that for an answer. That's great, you banked your points. But let's say you plugged that into here and this answer was rounded incorrectly now. So I want to warn you on this. What was that, 8 or something? Go and like copy paste or a second answer or whatever, the big old long stuff you just got into that. So in your work, you have to like keep it long. It's only in the final answers that you can truncate and round. So don't use truncated or rounded stuff to continue. Okay?
You could just leave it in that form, couldn't you? -32 times.
Oh yeah, yes. You could leave it -32t times a block. And this now velocity is in feet per second. Okay. So there's your intro on position, velocity, acceleration, on motion. A little bit on speed. We're going to do a lot more data. We'll do even more data. Huh? So, one more concept. First, I'm going to give you an intro, and then we're going to do a little bit more with piecewise. We had this before this piecewise. We wanted to see where things would be continuous, right? So if I just wanted to know where things would be continuous, then what did we do? We set this equal to that when x was that, okay? To be continuous. But now we're going to have to see where things are differentiable. So we're going to find the derivative by taking the derivative of the pieces. And we're going to set the derivatives equal at that. But wait, differentiability still implies continuity. So then we're also going to set the originals equal at that as well, because we typically will have to do more steps. So let's look at number 7. So first we're going to look at the differentiability part. And then I know that that's going to imply continuity. But first we're going to go to the differentiability. Very here, okay? So I'm going to find f prime. A's and B's are numbers. So that would be 2ax, and this would just be a. Good so far. So again, these are just numbers. So if b was like 2, then that'd be minus 6. Derivative goes to 0. Derivatives of constants are zeros. A and b are numbers. Okay, so now I'm going to set these two equal when x is 0, just like we did with the continuity. And hey, I just found a. What's a? 0. So now I can go back to my f and plug in what I know for a. Yes? And now with continuity, I set these two guys equal when x is 0, but there's no x's. So I can solve for b. Okay, so this one was a kind of generic, easier one. Let's go to this one, and this is supposed to say plus c. Okay? So start with your differentiability. Did you get a to be 3? Am I going too fast? I know, I'm just trying because we have 2 more minutes left. So I set them equal to each other when x is 2.
Question asked.
Then I know that the differentiability implies continuity. So I'm going to have to go look now at the continuity, plugging a to be 3. So this would be x cubed plus 12, 3ax squared plus c. Oh, I told you this was a typo. The original problem should have said plus c there. Yes, thank you. 3x squared plus c. Thank you, Ariana. Okay. Now are we good so far? Know which part, Lamb?